Okay, this is a video for Unit 10, Topic 2, which is the segments, how to figure out different measurements of segments in circles. So, a tangent line, so again, this is segments in circles. My pen isn't working. There we go. So, segments in circles. Okay, a tangent line intersects a circle at exactly one point, and that point is called the point of tangency. In this case, A would be the point of tangency because that's the point that this tangent line, AB, intersects the circle, particularly the radius at a 90-degree angle, so point A would be our point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if you have a tangent line and you draw a radius to it, it's got to be perpendicular to that. Otherwise, it's not a tangent. Otherwise, it's either basically not going to intersect the circle or it's going to intersect it in a couple different places. But there exists, if there's a line that's going through the circle in just one spot, there exists a radius that is perpendicular to that. Okay, so determine if AB is tangent to the circle. So with all right triangles, so since this is a right angle here, if this line is a tangent, then this would be a right angle. If it's not a tangent, then the radius isn't going to be a right angle to that. So what we really are doing is Pythagorean theorem. So your favorite thing is back. So we're going to be checking to see if the side lengths A and B squared add to equal C squared. And remember, the A and B always are the two legs, the two sides that border the 90-degree angle. So across from the 90 is always C. It's got to be the longest side. If it's not the longest, then you maybe you set it up incorrectly. But this always has to be the biggest out of the three numbers. So 8 squared, 15 squared, and then 17 squared was over here. Because clearly, if I put 17 squared and added something else, it's going to be bigger than either 8 or 15 squared already because 17 is already a bigger number. So the biggest number has to be on the side by itself. Okay, and then you would actually square each of these and see if they're equal. Alright, so for, if I do the workout for this one, it's going to be 8 squared, so 64, and then 15 squared. So 64 plus 225 equals, and then 17 squared is 289. 225 plus 64 is 289. So this one, the Pythagorean theorem does work, which means it is a tangent. So AB, that line segment, is a tangent to the circle. So it's meeting the circle in just one spot. And then you would do the same thing for 2 to check to see if it's a tangent. So be careful on this one because the 5 that they're talking about here is only from here to here. To get this segment, well, it's a radius of the circle. So anything that's going from the center of the circle to the edge of the circle is the same on any circle. So these radius are the same. So this part would be 11. Okay, so really you're checking to see if this is a right angle. So you would check 11 and 14 are your A and B, and then your C is really the combination of these. So 16 would be C. And you would need to check to see if those work out. Okay, and then the next couple, they're telling you if JK is a tangent, so that means this is a right angle, and this Pythagorean theorem will work, find X. So we're just going to be setting up the Pythagorean theorem to find the missing side. Again, C is the side across from the 90, so you can solve the Pythagorean theorem for side C. And we've done that plenty of times. So I'll let you try this one. On this one, again, this 7 is only from here to here. And the reason I know that is because the hypotenuse, which is the longest side, if that's only 7, then this side can't be 11. So it's got to be, 7 has to be only talking about from here to here. So this other piece is going to be 11, and this whole side is going to be 18. So we're going to check x squared plus 11 squared, because A and B are the two sides that touch the 90, so the two legs of the triangle, to see if it equals 18 squared, and then we would solve for x. Okay, to solve that, we're going to square 8 15 and square 11. And then we need to get x squared by itself. Right now it's added to 121, so we want to subtract 121 away. Okay, so that's 203. And when we get x, it's around, I'll put approximately 14.2. Okay. So that's the length of this side. Okay, so a bunch of Pythagorean theorem ones. For these, you're checking wherever the right angle is. X is from here to here. What you can do for this one to make it a little less difficult is to call this whole thing y and just solve for y. So you would do 10 squared plus 24 squared equals y squared. And then once you get y, subtract whatever this would be. So the radius is 10 here. So subtract 10 from that, and the remainder of it is going to be x. Okay. So that'll save you a little bit of having to do x plus 10 in parentheses squared. So again, you want to do it that way. Solve for y. So let's say y is 26. Then you would put 26 in for y and subtract out 10, so x would be just 16. Okay. All right. On number 6, the 11 is just going for the radius, so this is also 11, so be careful when you're doing that. And you can do the Pythagorean theorem again with the tangent. And 27, number 7, same thing. So Pythagorean theorem over and over for these. You can find this whole side, again, as y. If they don't give you one side, you can call it y. And then find y, and this time you're going to be cutting it in half. So once you get y, x is equal to half of y. So whatever you get that number, because x is only a radius, you cut the diameter in half. Okay, but you're doing the Pythagorean theorem for all of those to check for the last side. Okay, and number 9, they give you the radius as x. So this radius side is going to be also x. So when you set your equation up, this side is really going to be as an expression x plus 10. And I'm going to show you how to factor, or how to FOIL that out. So you have on the right triangle these two sides, LJ and then JK are your legs, so it's x squared and 20 squared equals, and then you put x plus 10 in parentheses squared. Okay, so when you're solving this, you get, this side's pretty straightforward. But x plus 10 squared means x plus 10 times x plus 10, and you have to FOIL. So you're going to do first terms multiplied together. It's going to give us x squared. Outer terms multiplied together, which is x and a positive 10, is going to give us plus 10x. Inner terms multiplied together is going to be plus another 10x. And then the last terms in each parentheses multiplied together is going to give us the 100. So again, that's FOIL for FOIL. First terms, which is x times x. Outer terms, which is 10 times x. Inner terms, 10 times x. And then last terms, 10 times 10. Okay, so then when we do that, we get x squared plus 20x, combining these two like terms, plus 100 equals x squared plus 400. Alright, what the nice thing is that the x squared is on both sides, so when we subtract x squared from one side, it actually comes off of both, and then you can just continue solving the algebra for x. Okay, the next part is more tangent line properties. So if two segments from the same external point, so B is the external point, are tangent to a circle, so this AB is a tangent and BC is a tangent, and they're tangent to the same external point, then they have to be congruent. So this segment will be congruent to this segment. Okay. The reason why that is because if we were to connect this part here and make two triangles, if they're tangents, they're right angles, so we know that they're right angles. And then this is a radius, so it's the same as this. And the shared segment BD is obviously the same because it's the same exact segment on this triangle as it is on this one. So these triangles are congruent by hypotenuse leg. So before I have this side, those two have the same hypotenuse, those two triangles have the same hypotenuse, and have one leg that's the same. So the triangles are congruent by hypotenuse leg, which means all the rest of their corresponding parts are congruent. So these two angles would be congruent, these two angles would be congruent, and these two sides would be congruent. So the easy of it is that the two tangents drawn to the same point are equal. So if a polygon, which is any straight-sided figure that closes, is circumscribed around the circle, so the polygon encloses the circle, then all the sides are tangent. So these are all tangents, which means these two, since they're both going to point B, would be equal. These two would be equal, and then these two would be equal. So any two that are drawn to the same point, so DA and AF would be equal. Because it's like this one, but it's basically like there's extending all the sides. Okay. So for the setup for these, you would just set any two segments drawn to the same point as equal. So I'll do 12 and 14 on this part, and then the rest of them I'll let you try. Okay, so for number 12, SV is in the middle here. They want us to find SV. So things we should already automatically know. If VT is 17, then one more segment should be 17 on the picture, because this VU is also a radius, so that's 17. And then these two TS and US are both drawn to the same point, so those two things have to be equal. That's what the property up there was telling us. So 10x minus 41 has to equal 4x plus 7. And we would solve for x by moving the 4x over and the 41 over. So we get 6x equals 48, and then we divide both sides by 6 to get 8. Okay, so when we plug 8 in, 32 plus 7 is going to be 39. And then if we just double check, 80 minus 41 is also 39, so we did it correctly. But they want SV, so because these are tangents, they're 90 degrees, and we're going to do Pythagorean theorem for one of the triangles. So we have a 17 and a 39, and we just need to do Pythagorean theorem to find SV, which I'll call Y, since we already had X in the picture. So across from the 90, that's going to be the side C, and I'll let you solve the Pythagorean theorem for Y. Okay, for 14, find the perimeter of the quadrilateral. So to do that, remember every two that are drawn to the same point are equal. So if this is 27.1, and that's talking about from here to R, then this part is 27.1. Okay, this whole line is 52.5, so to get from this point to S, they have to total 52.5, so we'd subtract 52.5 minus 27.1. So this part's going to be 25.4, which means this part's going to be 25.4, because those two are both drawn to S. This is 23, so this is going to be 23. And then we do subtraction again. So this is going to be 14.5 and 14.5. Okay, so then for the perimeter of the quadrilateral, we're going to add the 37.5, that's the whole side, so we've accounted for both of those. Then we need to add both of these, so the 14.5 and the 27.1. Then we can add the 52.5, and then we need to add both of these. So we're going to be starting with 37.5, adding 14.5, adding 27.1, adding this whole side together, 52.5, and adding 25.4 and 23. So the perimeter is 180. So normally sides don't equal 180. This one just happens to equal 180, but a lot of times people will get confused and think that sides equal 180. Only angles sum to 180 for a lot of the different types of angles, so like linear pair. And sometimes on circles, like if you were given a semicircle, that would be 180. But side lengths don't, or lengths don't typically equal 180. This just happened to be 180. Okay. But again, everything that's drawn to the same point, every two line segments that are drawn to the same point are equal. So So those would be equal. Those would be equal. Those are 23, and they would be equal. This is a 23. And those would be equal. Okay, and then the last of this paper has segment lengths formulas. So if you have two segments that intersect to two chords, or they could be secants, they could continue past the circle. If they intersect, then A times B equals C times D. Okay, so whatever these two numbers are, they multiply to equal this product of these two. That's type 1. If they intersect outside the circle, then it's the outside piece times the whole length, which is A plus B, equals the other outside piece times the whole length, C plus D. And then if it intersects a tangent outside the circle, then because this one doesn't have two pieces to do, you just do A times A, or A squared. And then B plus C would be this other piece. So you still do the outside piece and the whole thing. So those formulas are going to be just important to set up the problem, and then it's algebra from there. So I'll just set up a couple of these, and then I'll let you solve it. Okay, so for this one, A in this case, so basically A and B are the two segments on the same line. So it could be these are A and B or these, but 14 and 15 would get multiplied together. They're on the same line, and then 10 and x would be on the other side of the equation multiplied together. And then you'd just be evaluating that. So 210 equals 10x, and dividing by 10, x equals 21. Okay, doing number 3. 24 is on the same line as this 24 goes here, and then x plus 7. Okay, so remember with the parentheses you have to distribute the number outside to both of the terms inside. So 24x plus 24 times 7 is going to give us 168. 27 times 5 is 135. And then we can solve the algebra. So subtracting, if I want to move my x terms first, I have to subtract 24x from both sides. So 168 equals 3x plus 135. Subtracting 135 is 33. So dividing by 3x is 11. Okay. Occasionally they want you to solve x and then plug it into a particular segment. Plug it in where you need to and then add it to the segment. I don't think I did that one. I did the key. And so this one, once you find x, you want to find the whole length of this line. And then TQ, same thing. You want to plug it in just this to this piece. Okay, these you're going to be using type 2. I'm going to do number 6. So it would be, I'm just rewriting the formula from above. Okay, so the A and the C are the outside pieces. So this would be A and this would be C. Or A and C as long as they're outside. And then the whole length. So B would be with A and then D would be with C. So the pieces outside are the ones that get multiplied on the outside, and then the inside one adds the whole line. So it's 10 and then 10 plus 42 equals 13 and then x plus 13. So you can evaluate this whole thing. So 52 times 10, it's going to be 520. 13x plus 169. Okay, so we need to move the 169 over. So 351 equals 13x. And x is 27. Okay, this one wants us to find NL, so we would plug in x is 27, and then NL is going to be 27 plus 13, or 40. Okay, and then you have some on the back where you have to do you're having to square certain things. Let's see, I'm trying to find ones that are a little more challenging than others. I'll just set up number 8 just kind of so you can see kind of one of these type. So it's the outside piece times the whole length. The whole length of this would be x plus 8 plus 12, which is really like x plus 20 for the whole length. So it's going to be x plus 8 is the a part, or is the b part, plus a, so it's really x plus 20, but I'll write it that way. And then 15 times x minus 1 plus 15. So it's 12 times x plus 20 and 15 times x plus 14. Okay. Then you solve for x and plug it in to yz. Couple of quadratic ones, and then number 13, for instance, let's say 12 times 10 is going to equal x plus 6 times x minus 1. So you may not remember how to solve this from Algebra 1. That's okay. What you're looking for is two numbers that multiply to give you 120, and one number is, the difference between these is 7 units. So one number is 7 times bigger than the other number. So you can actually just guess and check. So the way I got 7 times bigger is that number plus 6, so let's say the number is 5. 5 plus 6 and then 5 minus 1 are going to be 7 units apart, because I don't know that it's 5, but I'm just saying whatever x is, if you add 6 to it, it's going to be 6 above x. If you subtract 1, it's going to be 1 below. So they're 7 units apart from each other. So you would want to guess and check and see, okay, 120 divided by, let's see, I would just try 6 first. Those are 14 units apart because 20 and 6 are the two numbers we got. But we only want them to be 7 units apart, so we would try maybe 8. Okay, 8 and 15 are 7 units apart, so 8 and 15 would be the two numbers that these need to be. And obviously 8 is going to be this one, and 15 is going to be this one. So you can solve either one of those. So x minus 1 equals 8, which means x is going to be 9. Okay, that's one way to do it. The other way is to actually do the algebra the way that you did it last year. So when you distribute this, you get x squared plus the outer terms, which is actually minus 1, x plus 6x, and the last, so I did first terms is x squared, outer FOILing, outer is negative 1x, inner 6x, and then last. So we get x squared plus 5x minus 6 equals 120. Okay, when you're doing this, you have to move the 120 over. So it's going to come x squared plus 5x. We subtracted 120, so it's going to be negative 126. So now we need two numbers that multiply to give us negative 126, but add to give us 5x. So we're back to having to do the guess and check thing. That's why I think it's easier to start it up here. But 126, I would try dividing it by, it ends in a 6, so possibly dividing it by 6 would give me 21, so that's a difference of 15. That's too big of a difference. We only want the difference to be 5. So 126 divided by 12. Nope, it's going to be 10.5. 126 divided by, so 15 is not going to go into it. It ends in a 6, so maybe like 6, we tried 12. 18 and 7 is too big, so maybe 9, because 18 and 9 are divisible, so 9 and 14. So x, 9 and 14 are going to be their two numbers. We want the bigger one to be positive, because when we add the like terms, we want to come out positive. So in order for this one to equal 0, x has to be 9. In order for this one to equal 0, x has to be negative 14. And we want to take the positive values because we can't have a negative length. Okay, so x is 9. Okay, so those require a little bit of effort. If you can get the setup part, I'm good with that. You don't actually have to do any of this on the EOC. So if you can set the ones that are quadratics up, it's a good little challenge for practice to solve it, but it's not essential. Okay, let's do one of the ones where the x is on the outside, because I didn't do one of those. So number 14. So x is on the outside, and then the inside would be x plus 5, or the whole thing would be x plus 5. And then this one would be 4 on the outside, and the whole thing would be 4 plus 2, so 6. So we get x squared plus 5x equals 24. But right here, actually, I would stop and say, okay, 24, two numbers that multiply together, that equal 24, and one's 5 times bigger than the other. 5 units bigger than the other. So to get x times x plus 5 has to equal 24. So 24, let's say, we know it's divisible by 12, but 12 and 2 aren't 5 units apart. We need them to be 5 units apart, because if one of them is just x and the other one's 5 more than that, they're 5 units apart. So we know also 8 and 3, those are 5 units apart. So that's going to be, this one's going to be the 8, and this one's going to be the 3. So x equals 3. Or you could do x plus 5 equals 8 and solve for that. So it's 3. If that didn't make sense, you can solve it using the quadratic way, but I feel like if you understand this, then you have to end up doing this at the end here. It's just more steps to do it first. So, okay, that's it.